Welcome, everybody. My name's Gary. I'm just going to be up here for a minute to introduce our presenter and take care of a couple of pieces of housekeeping. On your chairs when you came in, there's a little speaker evaluation form. If you want to take a couple of seconds for us and fill those out before you head out the door, turn them in at the back. We've got a nice little gift for everybody as they leave today. The other thing I wanted to quickly mention was that we are having the Cisco Code Word program or challenge. If you picked up a card on the way in, each Cisco activity that you go to during the course of the day has a different code word. Get a minimum of 3, take it back to the Cisco booth this afternoon. You're eligible for drawing for a really nice prize at the end of the day. The code word for our session here is OpenStack. He's nodding knowingly. Yes, okay. So with that, I'm going to introduce our presenter, Narendra from Cisco, one of our product managers, and he's going to tell us all about NFV from data center to the edge.
All right.
Thank you, Narendra.
Thank you, Gary. Good afternoon, folks. Thanks for being here. With all the music playing and the lights, you wish it was a Sunday, but it's not. All right, so you got to deal with me. Hey, thanks for making the time. So we have this competition going on. Make sure you pick up those little cards, fill in all the keywords, and visit the Cisco booth. I think today there's a drawing at 6 p.m., I believe. So, lots of good stuff to be won. At the same time, learning a lot of good stuff on OpenStack. All right, so what we're going to talk about today are some of the high-level trends, as well as a framework for NFV deployments, as well as where is NFV heading, right? We used to see this mainly from a data center deployment point of view, but it's essentially NFV is going places. And we're going to take a look at where is it going, why is it going where it is going, what are some of the implications of that, what are some of the considerations that we need to have when things are changing while things are still being innovated, right? So first and foremost, what's the high-level view with NFV, right? NFV continues to play a very important part in the service provider transformation. It's one of the 4 key pillars of SP transformation. Service orchestration, one of the essential ones with automation. Anywhere and everywhere you go, it's all about automation, 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 and that's very important because that brings in a lot of efficiencies and intelligence into the entire infrastructure. So that's one of the pieces. The second one is NFV, Network Functions Virtualization. Brings a lot of goods in terms of how we deploy our network assets, network instances, networking capabilities, as well as maintain, manage them, change them, and such. The third one is software-defined networking, which has been going on in parallel with NFV. And the fourth one, obviously, is some of the traditional aspects of networking still remain as they are because of the value they bring and continue to provide, right? Bare metal workloads, etc. So what are we seeing? What are some of the trends, right? So these are all surveys, very well-known surveys. This is from IHS. On the right-hand side, on your right-hand side, you see that there is a survey from 2016, and the left-hand side is a 2017 survey. Some of the things changed between 2016 and 2017. If you observe, SPs wanted to use software for quick revenue and a whole bunch of other motivations, but that changed over a year's time in 2017 to say, use standard COTS hardware, as well as introduce new services in a very flexible manner and drive those business outcomes in a very quick motion, rather than having a long lead time in terms of introducing or decommissioning any of the services an SP would provide. The second aspect of this is what are the drivers of that? And again, between 2016 and 2017, certain things have remained common, right? Be able to provide agility and flexibility in deployments, has been one of the key aspects that has been consistent regardless of whichever year it has been. While some of the OpEx priorities have changed because there is a view that if we get to the flexibility and agility part of it, OpEx can be managed. OpEx will change its shape as we move along in deploying virtualized workloads. The third aspect of this is, what do you want to run on this? When we say NFV, what are some of the lead use cases? What are some of the things that our customers are looking at deploying? So SP mobility, virtual CPE, business services, CDN, data caching, those are some of the lead examples of the use cases that customers would like to run. And if you look at this chart here, many of them basically fall into one or the other categories in mobility or managed services or CDN. Okay, so those are the use cases, those are the lead use cases that we want to go after, but at the same time, how quickly do we want to go there, right? Do I want to change my entire infrastructure in about 6 months, a year, 2 years, 3 years? What is the view on that, right? So the answer is, it's going to be a transformation. It's going to be a journey as technology evolves, as innovation happens. It also is going to take some time for our customers to move from a physical-based workloads to a virtual set of workloads. And many of our customers are looking at 5 to 20% of their workloads to be moved into a virtualized environment. And the rest of them will take their own reasons and time to get there, but there is a vision for that. But again, there is also a timeline in terms of how customers are looking at this. And this is very critical because we need to realize that as we evolve OpenStack, as we evolve other things in our ecosystem, it's going to take a bunch of things to bring together all of these pieces to enable the transformation. And as we change, as we evolve things in the way our OpenStack summits have brought in the new topics, right? It's going to have an impact on how this transformation will work, and we'll talk about it. No change here, right? These are still the fundamental pieces of what we call as the ingredients for successful NFV in terms of virtualization, right? We need to touch upon all of these aspects when we are talking about virtualization if we want to make virtualization real as well as deployable, bring business outcomes out of it at a manageable TCO. So, it starts with the virtualized infrastructure manager. In the virtual machine world, it's the OpenStack, and the popular one on the container environment is Kubernetes. There's the infrastructure management. Then there is, of course, when we always say that the N in NFV, involves a lot of packet handling, packet pushing, packet management. So when we do NFV, it obviously is about packet handling. So fast data plane on an x86 platform. When you have a generic x86 server, in the way that we want to call it, how do I make sure that I have the most performance gained out of that system? What are the tuning mechanisms that I need to use? What are the virtual switch technologies that I need to be using, right? So DPDK, SRIOV technologies, FD.io, which is an open source project from Cisco for the popularly known virtual switch VPP, vector packet processor. The next one is the data models and orchestration, right? So there's the standards bodies with IETF and such, as well as the models themselves. There's quite a few popular ones. Infrastructure does not involve only compute, only the packet handling part of it. It also involves the storage aspects, as well as how do we deliver software, how do we manage software, how do we update software. So Ceph, Linux, Docker as examples show up very often. And of course, how do we orchestrate any of the networking configurations, management, make them seamless, make them flexible, changeable very easily, SDN, right? VTS and Cisco ACI are some of the Cisco examples, ODL being the open source as well as others, right? This is just a sampling, not a marketing slide or a Cisco push. It's a sampling of what are all the components, where are all the touch points when we look at NFV. The last is chaining and connectivity, right? Again, there's a whole bunch of things that are happening here with NSH, service chaining, SFC, some driven by IETF, some driven by other communities. Okay, so all of those are the ingredients, but there is also a common sort of tie-in to all these things through ETSI, OPNFV, and such. So you'll see quite a few presentations here from either of these bodies. OPNFV, being a telco-specific community, has a whole bunch of presentations, including from us. All right, so if those are the ingredients, then how do the pieces come together or have been put together by ETSI? What's the framework that drives NFV? So this is the ETSI NFV reference architecture. Any and every document should have this. This is the blueprint. This is the framework along which we actually work. And on the right-hand side on the left-hand side to you of the slide, that's the framework, and that consists of two pieces. The bottom half is the infrastructure, physical infrastructure, and the virtual infrastructure. On top of these run the workloads, and to manage those workloads, you have virtual network function manager, as well as the network orchestrator. And all of these come together on the right-hand side in the Mano framework. And when we say NFV infrastructure going forward, it's the bottom half of that in the red box, the physical infrastructure as well as a way to have a virtualized software infrastructure on top of it and offering you a cloud to run your virtual workloads. So that's NFVI. NFVI is a combination of the hardware and software around that red box. And the NFVI is the hardware-software combination. And Vim is the virtualized infrastructure manager, and the most popular predominant virtualized infrastructure manager is OpenStack for service provider environments. And Vim is, think about it as a software platform, the glue that brings all of the hardware together and offers it up as one single entity to run your virtual machine VNF workloads. Here's the framework again, as similar but set in a different way. The bottom half again is the infrastructure, top half is the VNFs and the orchestration and management. And what does Cisco offer in this regard? Right, the bottom half is Cisco NFVI, is a full-fledged solution, and that Cisco NFVI consists of Cisco Vim, Cisco Virtualized Infrastructure Manager, NFVI monitoring, unified management, SDN controllers as an option, as well as, of course, the hardware with UCS and Nexus 9000. On the orchestration side, VNF Manager is Cisco Elastic Services Controller, and the network orchestrator is Cisco Network Services Orchestrator, which is the TAILF acquisition that we have had. Okay, so switching gears here, so we kind of understand the framework, we know how things work in the virtualized world, what are all the touch points, what are all the components. Now, what are some of the requirements that have been common across all of the customers that we have worked? And this hasn't changed. This has been the constant for the last few years for us. But it's important to identify and level set what these requirements are. One of the first ones is carrier class performance. If I'm going to move my workloads and run them in a virtualized environment, that doesn't mean I'm going to compromise on performance. That doesn't mean that I'm going to invest 3 times, 5 times, 10 times what I was investing to get the flexibility of running things in a virtualized environment. So I need to get the best performance out of the generic hardware on which I'll be running. How do I do that? Use case agnostic. All right, so this is an infrastructure. Previously, infrastructure means boxes. Boxes means cables. And there used to be a clear isolation between them. However, now the infrastructure is one big platform, distributed platform called the cloud. If that's the case, then that cloud needs to be able to accommodate any and all workloads in a fair manner to work and interwork amongst each other to bring a solution to our customers. So that's key. So that's use case agnostic. Open standards based. So how do I bring that use case agnosticity? The easiest way to do that is have a standards-based environment. So if this is the infrastructure, have a standard way to interact with that environment so that everybody has a well-known interface through which they can deploy workloads, move workloads, and such. As well as that infrastructure needs to be modular and elastic so that If I have a business need to increase capacity, I should be able to do that seamlessly. If I have a business need to move capacity somewhere else, I need to be able to do that too. So, okay, I got the performance, I got the interoperability, all those pieces figured out. How do I run this thing? How do I manage? So that's where the ease of use with a unified management system comes into play. All right, I got the hardware, I got the software platform. How do I lifecycle manage these things together? And if I have a bunch of these things lying around my network across the geographies, how do I manage all of these things through a single console? I'm calling them things because I'm trying to kind of build to the point where we have multiple clouds spread across the environment. Okay, we got the management figured out, at least the requirements part of it. Then how do we operate this? How do I operate this environment when I actually am running my customers' workloads with an SLA, which I am charging them for a byte, for a minute, for a second, whatever that metric is? How do I make sure that this cloud, this environment functions well as it can be operated on a day-to-day basis, regardless of whether it's day 1, day 2000, day 5000, and how does the support model work? So this is where we have seen that there has been a unanimous push from our customers to say, when I have to take things to production, when I have to run these things, I need a single throat to choke. I need a single vendor to tell me, this is going to work, this is how it's going to work, and if it doesn't work, here's the number to call. The next one is, okay, so we have the support figured out, everything is working, but again, remember, this is running your customers' workloads, which means security is of utmost importance here to make sure your customers' information is securely isolated. We are also compliant to many standards and other geographic requirements and such. So security becomes an important aspect. So we really cannot ignore that. So it's as simple as securing what's being transmitted on the wire, securing one customer's traffic versus another customer's traffic, and many, many aspects of that. So these are the half a dozen requirements that are very common in any environment, in any customer, when it comes to NFV deployments. All right, so what's Cisco's architecture for this overall? So again, not changed, it's more of a level set here. This is the Cisco NFV architecture, top to bottom. The bottom half, again, is the infrastructure part of it, around the green box, and the top half is the workloads, VNFs, orchestration, and management. The bottom half consists of physical hardware, compute, network, storage, and all of this offered up as a common cloud platform by what we call as Cisco Virtualized Infrastructure Manager. So Cisco Virtualized Infrastructure Manager, based on OpenStack, Red Hat OpenStack, basically takes all of this hardware and creates a software platform on which you can onboard workloads, manage workloads, lifecycle manage the infrastructure and such. So that's the Cisco Vim part of it. The second aspect is SDN as an option. You can integrate, so long as you're interoperable with OpenStack, with the ML2 model, then you can integrate SDN controllers into this environment as an option. And we have easy access to Cisco products, so we've integrated with Cisco VTS and Cisco ACI. The third aspect is the unified management piece of it. So there is a unified management plane that can actually manage this entire infrastructure, physical and virtual, at the infrastructure layer. And the fourth aspect to this, and the most important one, is how do I monitor this infrastructure? How do I make sure that when things go wrong or about to go wrong, I'm able to trace that? When I'm running a workload, imagine you have a server, you have an operating system, KVM, virtual machine ports, virtual machine operating system, and then the workload, right? Now, if a workload is running on a particular server, how do I know if this server goes down, what's the impact on my customer environment? If this server goes down, does it mean that all of my customers are going to go down? Does it mean that 10% of my customers are going to go down? Or it means nothing because I have a high availability set in a way that while I recover this server, things continue to run in a seamless fashion. So that's what monitoring and assurance can do for you. And of course, the top off is all the VNFs, Cisco VNFs, third-party VNFs. So long as they're all interoperable through an OpenStack interface, we're good to go. And the VNF manager and the NFVO. Okay, so that's the platform. So what are the use cases? Right? The use cases are business services, virtual CPE, etc. We'll talk about a little bit at the later part of the presentation. Mobility, IMS, load balancers, media, content caching, and any other third-party VNFs, DHCP, you name it. Any essential services also that you run today in your network environment, you should be able to run in the virtualized environment. And the key aspect is there is a separation between all the use cases and the infrastructure. And that separation is connected between the two entities by only one thing, which is well-defined standard OpenStack interface. So any and all interactions into the platform happen through that well-defined interface. It's open, it's well-defined, specs are out there, so it's very clean, and hence we can achieve that use case agnostic infrastructure goal, as well as being able to interoperate with any and all VNFs. All right? Okay, so how do we bring this all together? Right? So remember, it's open source, it's a lot of joint efforts. At the same time, the customer says, we need to have a single throat to choke when I want to operate this system. So how do we make that happen? So this solution, Cisco NFVI, comes through a partnership between Cisco, Red Hat, and Intel. Cisco, the #1 networking vendor. Red Hat, #1 enterprise open source vendor. Intel, #1 x86 vendor. All right, so we bring all of these together in partnership. And at the same time, Cisco takes the lead to be the owner of this NFVI solution. And the support, everything flows through Cisco. And Cisco is the front end for this solution. And what does that partnership entail? What do we do? Is it just a slide? No, right? From the previous one. We actually do a lot of things in the community. We are jointly involved in OPNFV, ONF, VPP, FIDO, FD.io, OpenStack, a lot of these communities. We drive joint innovation, we drive blueprints, we drive joint work, or just stabilizing things, quality control, you name it. We pick a few things and make sure they are taken care of. As well as we also do joint engineering work, forward-looking work, where we can harness the goodness of some of the functions that Intel brings in their chipsets with some of the functions that we have in networking, and perhaps there is a tie-in with security. So how do we bring all of that together in a seamless manner that again is performant, that again is open, interoperable, and such. We have joint innovation labs across the world where we showcase NFVI, VNF onboarding, you name it, all of those efforts happen on a daily basis. And of course, we also have the broadest combined ecosystem across the 3 of the partners. So all right, so that's the baseline here. So what's NFV, what's NFVI, how do we bring it together, what's Cisco's solution? Now, some of the customers, or many of our customers, have embarked on an NFV journey. We have customers in production, we have customers in lab trials, POCs, field trials today. And that's all driven by a certain set of assumptions, certain set of pieces of the puzzle that are already available out there. However, there is also this evolution of virtualization going on while things are being deployed, right? So what are some of those things, right? I'm going to give you a few dimensions of that and walk you through how this is going to impact the next 1 to 3 years of what we need to be doing here. So business services use cases. If you look at this picture here, probably doesn't say much. Well, okay, we have business services. They're all virtualized. It's a virtual CPE environment. It's a virtual firewall environment and such. At the same time, what's going on is what predominantly used to be an NFV deployment in massive data centers or imagined to be deployed in a data center, some of those same use cases, some of the same deployments are now being moved to a central office location, to an edge location. so that there is more proximity to the end customer while delivering these services. Previously, if you wanted to go close to the CEO, you would deploy a quote-unquote box. But now, if all of these are virtualized workloads, then how do I push this to that edge? How do I push this to that central office location? And what implications does that have? What happens to the footprint? What happens to the architecture? What happens to the design? What happens to HA? Those are some of the things that we need to think about. And it's forcing us to do that. So next one, mobility, video, and content use cases. This looks like a predominantly mobility use case picture, but if you look at it closely, right? So we got IoT coming at us, or probably past us already. We got 5G. We have a lot of things going on in the mobile world, and all of us have a mobile phone here and a smartphone. So we access email, we make cell phone calls, we make Wi-Fi calls, we check out social networks, as well as we also watch videos. So all of these things are coming together onto that single device. And when that happens, the way that these things can be delivered is changing because there is flexibility, because there is also this need of change in delivery mechanism because of the demand and things being pushed to the edge. If all of us are actually going to go watch, sitting in this room and watching this morning's keynote on YouTube, probably somebody who's delivering that video might be thinking, I wish I had something very close to the convention center so that I don't need to stream like 50 channels of YouTube of the same content from my data center, right? Very simple example, maybe hypothetical. What if I push something to the edge where I send one stream and then serve 50, 60, 80, 100 people through that edge location? Isn't that better? That means my infrastructure just moved out of the data center. My use case just moved out of the data center. My workloads moved out of the data center. All right, so now let's start thinking about how do I deploy that data center, how do I deploy that workload at the edge while I have a central NOC location, which is probably looking like a data center. So those are some of the things that come into play as we unpack this picture and imagine all the things that it could do, right? So this kind of summarizes that, right? Previously, it used to be a backend data center. You used to run a service on it, deliver it to the end customer, right? Second is you have a backend data center with a service, front-end data center with a service. All right, I kind of managed to optimize to a certain level and serve to my customer. However, as things evolve, and as we discussed, more and more things get pushed to the edge, and mainly the data plane pieces get pushed to the edge, which are heavy in packet, and that's when these deployments will change. That's when NFV, the shape and size and color of NFV will change. So how will that change? All right, so we talked about the delivery model. We talked about how things will move. Things will get out of the data center. They will go everywhere in the world. Fine. What does that mean? What implications does that have on the workloads themselves? Do they need to change shape and form? Absolutely yes, right? So previously, we used to have bare metal workloads, which used to be called as quote-unquote boxes. Move to a virtualized world. We can run things in virtual machines, maybe in a data center, maybe in a front-end data center. And in the future, things are going to go cloud native, things being deployed as microservices, containers. So now when that happens, how do I make sure that I can orchestrate these things, I can manage these things, I can monitor these things, right? And the truth of life is we are never given a clean-cut environment where it's only one thing. Now, how do I manage multiple different types of workloads in my environment while maintaining sanity, right? So if you had to put that change in workloads into how and which places they will go, right? This is a standard picture in terms of all the network deployment models. It starts from the customer premise all the way to a cloud-hosted environment. And basically, what used to be only in the data center, or what started off at the data center, will also now be going into a remote data center, a central office, an access location, and a customer premise, as well as on the other side of the data center too, right? Into a cloud-hosted environment or a co-located environment close to where other customers' workloads are running. So if that's what is going to happen, then what are some of the infrastructure and orchestration considerations that we need to have? One of the first things is obviously, what are all the deployment models, right? So it could be an edge compute location, tens of virtual workloads, hundreds, thousands, and hundreds of virtual workload production services by themselves. And you got to have a unified control plane and a unified data plane across this infrastructure, regardless of where your workload sits. You got to have that unification to make things happen. Again, back to the 6 high-level requirements that come from NFVI, but actually, drive NFV. As well as, the shape and form will change of a site, of an NFV deployment, of an NFV data center. Data center is no more a data center, right? It could be a half or a full rack, a multi-rack, couple of racks, maybe a micro node or a nano node or a nano location. And all of these happening at the same time, right? So once you let your VNF get out of your data center, it basically can go any place, right? And all these happening at the same time. And it means we have a lot of options. It's fun both ways. So, we have virtual machines, we have containers, all right, we have Kubernetes to manage containers, we have Docker to serve those containers, all right, we have KVM to manage, we have bare metal to manage because some workloads would allow to just stay on bare metal. So how do we bring all this together? How do we orchestrate these things? How do we run these things, regardless of, again, what shape, kind, form your network function is, all right? And when we have that, how do I provide high performance? That requirement has not gone away. Carrier class requirement has not gone away. How do I provide automation so that things can be easy, things can be manageable? How do I do lifecycle management, whether it's, again, day 0, day 2000, day 5000? High availability. If one site goes down, what happens to the workloads? If one server goes down, what happens to the workloads? If one network function goes down, what happens to the workloads, right? Oh, great. So we got all that figured out. So then how do I stitch all these up in terms of networking models, right? There's one workload, virtual machine workload, sitting in a faraway data center, talking to another one at the edge location. How do I stitch up the network for that? How many times am I going to do the encapsulation and decapsulation on that packet? Does that really matter? What happens to round trip delay? What happens to throughput? So all those come into play. And again, so we always want to kind of have fun in the technical aspects of how to push the packet and stuff, but the people who run the show ask us, how do I troubleshoot? How do I log things? How do I actually look through the logs to even make something out of it when there is problems? Okay, you made my VNF get out of the data center jail and let it go anywhere and everywhere. What happens to security? So these are some of the things that we need to think about while these transformations are going on, and it's critical that these are solved because this is real, this is happening. So one of the aspects is unified control plane and data plane, as well as you integrate your cloud and WAN management plane together, right, with end-to-end service orchestration and assurance. So from an operations point of view, right, again, just to reiterate, management and monitoring becomes very, very critical. I need to be able to manage and monitor many instances of this because some are small and many, some are big and few, but I need to be able to manage all of them together. I need to be able to manage footprints of various sizes, various types. I need to be able to manage the workload variations because some are packaged in virtual machines, some are packaged in containers, they're maybe sitting next to each other, maybe they're not sitting next to each other. How do we bring all these to bear? And of course, the day 0 to N operations like we discussed. So that's where we are headed in terms of NFV getting out of data center and into the edge, right? So summarizing, Cisco NFVI is still, will evolve through its journey. And we started off with a carrier-grade NFVI solution, which is based on virtualization, but that's now evolving into accommodating container workloads, bare metal workloads, with a common orchestration and management on top. Still being multi-use case capable, still relying on and compliant with open standards and open source, being very easy to manage, carrier-grade performance, high availability, scale, as well as some industry-leading partnerships. Last but not the least, a single point of ownership to run your customers' workloads. So we will evolve into the cloud-native environment as we go along this journey. That's all I had for today. In terms of some of the presentations, we have all these presentations going on. There's another one here right after this, as well as some on VNF benchmarking, fast data plane performance with virtual switches, all sorts of fun stuff. Catch one of the sessions here, or check out the YouTube channel, OpenStack YouTube channel. All of the session recordings will be available in less than 24 hours. All right, so now to the fun part of it. So we have the Cisco Code Word competition challenge going on. If you don't have that little card, raise your hand. You will get one. Collect 3 of those words. Go to the Cisco booth by 6 p.m. today, and some fun prizes to be won. And the code word for this presentation that you can jot down is OpenStack. All right, thank you for the time. Have a great summit.